Imagine looking up at the night sky after weeks of anticipation, telescope ready, only to find that something huge is missing. Known for its shining rings, the most famous jewelry in our solar system seems to have traded its iconic look for a plain, planet-only appearance. Where did those stunning rings go? Are they really disappearing before our eyes? Or is this another marvel of cosmic perspective? If you're curious about why Saturn's rings will appear to vanish in 2025, and what this means for astronomy and science as a whole, you're not alone. The truth is captivating, and the story behind this vanishing act is one of cosmic cycles. Fast-paced discoveries and humbling reminders about our evolving place in the universe. When people hear that Saturn's rings will disappear in 2025, it's easy to panic. Are these dazzling rings vanishing forever? Luckily, the answer is no, at least not this fast. In March 2025, the rings are going to appear to vanish when viewed from Earth. But this disappearance is an illusion. A trick caused by the alignment of Saturn's rings and the way we see them. Every 14 or 15 years or so, the Earth's orbit and Saturn's 29.5-year path around the Sun line up just right, and we end up seeing Saturn's rings edge on, rather than from above or below. Because the rings are extremely thin relative to their immense span, about 30 to 100 meters thick. Compared to a width of around 270,000 kilometers, they will look almost invisible, or like a sharp line through the planet's middle. This rare event is called a ring plane crossing. It's not the first time it has happened, and it won't be the last. When the crossing is exact, the rings lose most of their sparkle from our perspective. The last time we saw this effect was in 2009, and before that, in 1995. The next crossings will be in 2038 and 2039. But viewing conditions are best at certain cycles depending on the positions of Earth and Saturn relative to the Sun. However, there is another story running in the background. While this vanishing is temporary, Saturn's rings are, in another sense, truly vanishing over very long timescales. They're gradually falling onto the planet, a phenomenon called ring rain. This more permanent vanishing act is slow, measured in millions of years. But we were lucky to be here during Saturn's prima cosmic privilege that future skywatchers may not have. Saturn's axis is tilted at roughly 27 degrees, similar in amount to Earth's 23.5-degree tilt. This tilt, combined with Saturn's slow journey around the Sun, taking nearly 30 years for a single orbit, causes the orientation of the rings to change, as seen from Earth. Sometimes we see them at their widest, sometimes we see the underside or top side. And about every 15 years we see the thin edge, as though looking at a dinner plate from the side. When that edge is aimed toward us, the immense expanse of the rings, nearly as wide as the distance between Earth and the Moon, is squeezed into a thin line that's very hard to spot, especially with the limits of our telescopes. Light reflects off the flat, wide surface efficiently, but nearly nothing bounces off the much smaller edge, and so the rings seem to disappear. It's 4 amateur astronomers peering through a telescope or 4 naked-eye observers. Saturn will briefly appear to have shed its most recognizable feature. But almost as quickly as they vanish, the rings return to view as Saturn continues on its orbit. Tilting the rings so we once again see them from above or below, rather than at their knife-thin edge. The cyclical nature of these ring plane crossings has been a key opportunity for astronomers. Every time Saturn's ring plane lines up with Earth's, new moons have historically been discovered, and hidden features in the ring system get revealed, all because the usual glare of the rings is briefly subdued. It's like the universe is granting scientists a secret backstage pass every decade and a half or so. For instance, Galileo Galilei was the first to see Saturn's ears in 1610, but his telescope was too poor to resolve them as rings. In 1655, Christian Huygens correctly deduced that Saturn was surrounded by a thin, flat ring. In the late 18th and 19th centuries, several moons including Titan and Enceladus were discovered during ring plane crossings, enabled by the dimming of the bright ring shine. The Hubble Space Telescope imaged Saturn's rings at dawn in the 1990s, letting astronomers spot details in the ring plane and discover faint moons. The last ring plane crossing in 2009 led to observations of new moons and rings by both amateur and professional astronomers. March 2025 promises to be another such golden moment, but with a catch. This time, Saturn will lie very close to the Sun in our sky during the event, making observations harder and putting the challenge to skywatchers to catch glimpses during less than ideal conditions. Far from being solid disks, Saturn's rings are giant collections of tiny objects, ranging from grains as small as dust to icy chunks the size of boulders, some as big as houses, though most are closer in size to snowballs. The overwhelming majority of these particles are made of almost pure water ice, glinting and reflecting sunlight in the distant reaches of the solar system. The composition and structure by ring A, B, and C, rings, main rings, the brightest and most substantial. The B ring is the densest and most opaque, containing a huge proportion of the system's mass. These main rings are composed of up to 99% water ice, with some dust and rocky material mixed in. The A ring lies outside the B ring, separated by the famous Cassini division, a wide gap created in part by gravitational pulls from Saturn's moons. Fainter rings, D, E, F, G. The E ring, surprisingly, is built from icy plumes ejected by the moon Enceladus, while the D ring close to Saturn is silicate and organic-rich, less water icy, mainly composed of much smaller particles than the main rings. The rings are mind-bogglingly wide, about 270,000 kilometers, from inner to outer edge, but mostly only 30 to 100 meters thick, giving them their distinctive flat appearance when seen edge-on. Keeping all those tiny and not-so-tiny bits arranged in elegant bands is no small feat. Saturn, its graceful system, owes much of its stability to a class of moons known as shepherds. These are small satellites like Prometheus, Pandora, Pan, and Daphnis that orbit near or within the rings. How shepherd moons work. Gravitational herding. Their gravity pulls on the ring particles, either speeding them up or slowing them down, nudging them into distinct orbits and keeping gaps like the ENC and Keeler gaps open. Without these moons, stray ring material might drift away or fill in the gaps. Maintaining edges. In the F ring, Prometheus and Pandora, once thought to both be shepherds, now known that Prometheus plays the main role, prevent ring particles from wandering, explaining the sharpness and narrowness of this outer ring band. Creating structures. At certain points, collisions between ring material and shepherd moons generate waves, propellers, and clumps, contributing to the constantly changing, rippling structure seen in close-up images. Influence beyond Saturn. The principles learned from studying shepherds help astronomers understand ring behavior at other planets, and even in planetary disk formation around stars and exoplanets. The gravitational choreography between the rings and their shepherd moons is essential for the structure. Longevity and stunning beauty of Saturn's rings, while the rings' disappearance from view in 2025 is only a temporary illusion. A slower and more permanent vanishing act is happening, hidden from casual skywatchers, but seen clearly by planet scientists. The main culprit? Ring rain. This phenomenon describes how ring particles, especially the smaller ones, become electrically charged by ultraviolet sunlight or space plasma, and then spiral along Saturn's powerful magnetic field lanes straight into the planet's upper atmosphere. Here's what the science tells us. The rings are losing material at a shocking rate in astronomical terms. NASA estimates it's enough ice and water to fill an Olympus-sized swimming pool every 30 minutes. The water and dust from the rings ends up raining onto Saturn, detected as changes in the planet's ionosphere, upper atmospheric layer. Charged water molecules neutralize ions in the atmosphere, quenching electron densities and leaving behind faint dark bands when measured with infrared and radio telescopes. The loss comes from two sources: steady rain pulled in along magnetic field lines, and larger clumps and grains migrating in or knocked loose by collisions and micrometeoroid impacts. The Cassini spacecraft in its final grand finale orbits measured the rate at which this ring material is falling onto Saturn, helping scientists revise their estimates for how much longer the rings will last. How does ring rain happen? Particles making up the rings are constantly bombarded by tiny space rocks, micrometeoroids, solar radiation, and Saturn's own magnetic field. Some of these forces charge the particles, causing them to spiral down Saturn's magnetic field and fall into the planet's atmosphere. Others simply crash into each other, slow down, eventually lose enough orbital speed to get caught by gravity and descend to the planet below. According to NASA, its combination of effects means that Saturn's rings are steadily shrinking and will eventually disappear altogether over tens to hundreds of millions of years. Cassini's last dance, unraveling the mysteries of Saturn's rings for 13 years. The Cassini spacecraft orbited Saturn, sending back a gold mine of data and winning the hearts of space fans worldwide. Thanks to Cassini, our understanding of Saturn's ring system was completely transformed. Direct mass measurements. Cassini's gravity experiments mapped the true mass of the rings about 40% of the mass of Saturn's moon mass, or about 1.5x 1,019 kilograms. Structure and composition. Instruments on Cassini measured composition in unprecedented detail, confirming ice as the main ingredient, with a growing concentration of organics and rock closer to the planet. The spacecraft also discovered new ringlets, odd propeller features, vertical warps, and waves within the rings. The E-ring and Enceladus, Cassini's flybys of the moon. Enceladus revealed that water ice plumes erupting from the moon's south pole feed the E-ring, directly linking a moon's volcanic geyser activity to the sustaining of a planetary ring. Ring rain. Cassini's final orbits between Saturn and the rings gave direct evidence for atmospheric rain from the rings, confirming estimates made from remote Earth-based observations. Age of the rings, combining measurements of mass, pollution, and erosion rates. Scientists now believe Saturn's rings are strikingly young, perhaps only 10 million to 100 million years old. A fraction of the age of Saturn itself, over 4.5 billion years. Cassini's findings essentially rewrote our textbook understanding, showing that Saturn's rings are dynamic, changing, and living on borrowed time, at least on cosmic scales. Historical observations. From Galileo's ears to modern marvel, the fascination with Saturn's rings goes back over 400 years. When Galileo first turned his telescope to the planet in 1610, he described seeing Saturn with ears, bulges on both sides, which he couldn't resolve as rings. Over decades, astronomers used better telescopes and methods to clarify the mystery. 1655. Christian Huygens drew the first accurate diagram, identifying the ring as a thin, flat disk encircling Saturn. 1675. Giovanni Cassini discovered the wide-gap Cassini division that splits the main rings, showing the rings are composed of separated bands. 19th century. James Clerk Maxwell proved mathematically that the rings couldn't be solid, and instead must be made of countless smaller particles. 20th-21st centuries, space missions, Pioneer, Voyager, and finally Cassini solved more puzzles, revealing the dazzling complexity of Saturn's rings, their colors, clumping, moon interactions, and origins. Ring plane crossings have provided astronomers with the rare chance to see Saturn, almost bare, and to make discoveries that would otherwise be buried in the glare of the fully visible rings.
Saturn's moons,
partners in a celestial dance. While Saturn's rings are beautiful in their own right, their story is intertwined with Saturn's vast and still growing collection of moons. Some moons are large and heavily studied, like Titan, the lakes of methane and plans for new exploration, and some are tiny, it's barely more than a mile across, shaping and feeding the outer ring regions. But two moons in particular have caught scientists' attention. Enceladus. This icy moon is an active world. Shooting water geysers from cracks at its south pole, these geysers directly resupply the E-ring, making Enceladus a ring builder rather than just a bystander. Cassini detected organic compounds in these plumes, suggesting Enceladus may have an underground ocean suitable for life. Future missions, such as NASA's Dragonfly to Titan, will keep expanding our understanding of Saturn's complex moon family. Titan, Saturn's largest moon hidden under an orange, hazy atmosphere, also plays a role in the destiny of the ring system. Some theories suggest shifting moon orbits could help trigger ring formation or loss over hundreds of millions of years. The moon-ring interplay unveils not just how Saturn looks, but why planetary systems at large have such a wild range of ring and satellite structures. The future timeline. Cosmic clock ticking on Saturn's rings. While the 2025 vanishing trick is a temporary show for Earthbound viewers, the rings are, over the long term, eroding and will eventually disappear. The best scientific models put the remaining visible lifetime of Saturn Its majestic rings at no more than 100 to 400 million years, perhaps even less based on Cassini's findings of high rates of ring rain and inward migration of ring material. Over time, the sequence is likely to go much like this. Innermost rings, like the D ring, disappear first, as their small particles are lost faster to Saturn's atmosphere. Outer, brighter rings, like the A and B rings, persist longer. But their edges break up, and the broad, bright disk gradually fades. Final remnants become fainter, darker, belt-like rings, similar to the faint ones we see around Jupiter, Uranus, and Neptune today. Ultimate end. In a few 100 million years, all that will be left is a subtle glow around Saturn, with an occasional moon or clump bearing witness to one of the solar system's most awe-inspiring sights that we fortunately are alive to witness. Why does it matter? The scientific significance of ring disappearance. Why does it matter that Saturn's rings are fading? It's more than just the loss of a pretty planetary feature. The physics driving the ring's birth, evolution, demise, tie directly into major themes in space science. Clues to solar system history. The current short-lived shine of Saturn's rings means we may have gotten cosmically lucky. The rings are younger than the planet, and the timing of their formation gives us insight into moon collisions, planetary migration, and how the solar system has changed over billions of years. Modeling disk evolution, studying ring dynamics, moon shepherding. And material loss gives scientists a test bed for understanding how dust disks around young stars collapse to form planets. These processes occur on a fast-forward scale in Saturn. Rings. Atmospheric chemistry. The raining of ring material changes Saturn's atmosphere in ways that can be seen by instruments, providing a natural laboratory for learning about planetary weather, chemistry, and interactions between solid and gaseous components. Search for life. Discoveries like water geysers from Enceladus and ring-fed chemistry enhance our search for habitable environments beyond Earth. In short, the Vanishing Ring story is both a lesson in cosmic perspective and an active field of scientific exploration. Observing the 2025 event, what you can expect for skywatchers? The 2025 event is an invitation to be part of a rare cosmic occurrence. Even though Saturn will be near the Sun in our sky, making the exact moment of ring plane crossing hard to see. With good timing, a telescope, and a bit of patience, it's possible to glimpse Saturn nearly barren odd sight for anyone used to its ringed appearance. When? The rings will appear Ejon from Earth in March 2025. By summer and autumn, they'll gradually widen and return to their familiar angle. What to use? Medium-sized amateur telescopes are better. Skywatching guides will provide finder charts and best times. Saturn will be visible just before dawn later in 2025, at a low angle over the horizon. What you'll see, the rings won't be gone, just paper-thin and barely visible, making Saturn look like a plain planet with pinprick moons orbiting close. Experienced observers may spot shadows, faint lines, or even the moon strung out in a row. Professional observatories will use this opportunity to study details of Saturn's atmosphere, and it's tricky to spot smaller moons. Since the ring's glare won't wash them out, astronomers will be keen to discover any hidden phenomena. During this rare cosmic open window, why clear, simple science storytelling is essential. The tale of Saturn's vanishing rings is a model example for how science stories should be told. Clear, accurate, and easy to grasp whether you're 20 or 70, an astronomy buff, or just a curious reader. Scientific language should avoid jargon, metaphors, or unnecessary complexity, instead sticking to plain English and relatable concepts. Here's what matters for communicating science well. Start with a compelling hook, something that grabs attention. Like the question, are Saturn's rings really disappearing before our eyes? Use short sentences and everyday language to explain big ideas, break complex processes, ring rain, orbital tilts, shepherd moons, into clear step-by-step explanations. Avoid emotional exaggeration and keep the tone calm and factual even in the face of cosmic events. Invite the reader to imagine and reflect. We're reliving in a remarkable moment when Saturn still shines in full glory. Give practical advice for participation. How to spot the 2025 event, what to look for, and why it matters. Science communication is for everyone. When told well, stories like the vanishing of Saturn's rings become gateways to understanding bigger truths about our universe. Debunking common myths about Saturn's rings. Are Saturn's rings disappearing for good in 2025? No. The 2025 disappearance is an illusion caused by the thin edges of the rings pointing toward Earth. The actual material is still there, just turned edge-on to our view. The permanent disappearance refers to millions of years in the future, blink of an eye in solar system terms, but a very long time for humans. Is Saturn unique in having rings? All four giant planets Jupiter, Saturn, Uranus, and Neptune have rings. But only Saturn's are bright, wide, and so distinct. Jupiter, Uranus, and Neptune have faint dark belts that are barely visible even with large telescopes, possibly because their own ring rain and erosion occurred long ago. Will we ever see rings like Saturn's around another planet? It's possible. Astronomers spot dust, disks, and ring-like features around exoplanets and even brown dwarfs far beyond our solar system. One day telescopes may reveal rings even more spectacular than Saturn's, though. For now, Saturn is the crown jewel. Why bother studying the rings if they're temporary? Studying Saturn's rings tells us how planetary disks grow, change, and disappear, offering clues to how moons form, planets accrete, and even how the early solar system evolved. Saturn's rings in a human perspective. Why we're lucky. There is something poetic about living at the exact moment in cosmic history when Saturn's rings are at their brightest, boldest, and easiest to see. Earth had formed a few 100 million years earlier or later. We might never have seen Saturn's splendor, just a plain planet, eerily similar to the other giants. For skywatchers, astronomers, and curious dreamers alike, Saturn's vanishing rings are a reminder of how fleeting even the greatest wonders can be. That's all the more reason to watch, wonder, and appreciate the beauty while it's here. Conclusion. When the universe plays hide-and-seek, Saturn's vanishing rings are a cosmic trick-end, a cosmic truth wrapped in a lesson of perspective and patience. For a short time in 2025, they'll hide from us, only to return as Saturn continues on its stately orbit. But on a larger timescale, the rings are fading, a beautiful reminder that even the mightiest, most dazzling features in our skies are subject to change. Science provides not just the answers, but the best questions. What will be discovered during this rare ring plane crossing? How do cosmic cycles continue to shape the dance of rings, moons, and planets? And what other wonders will the universe reveal once we're given the chance and the curiosity to look? So when you look up and see Saturn, whether it wears its dazzling attire or stands plainly in the sky, remember, you are witnessing one of the grandest shows in the solar system, and the story is far from over.